let's jump in here, give you a bit of an overview. What I want to accomplish this morning is to talk about why Elixir is unique and how it solves common problems uniquely. So we often talk about right tool for the job. Well, I want to use Elixir as part of those conversations moving forward. What are some of the techniques and dependencies that come with those techniques that we're accustomed to using in product development? Why is Elixir advantageous in this? What are some of the components that make up Elixir? So processes and behaviors are crucial as part of that ecosystem. And also, what are some of the success stories, right? Give you a chance to ask questions. So we'll dive in. But before I go too far, I want to encourage you to like and subscribe. So if there's anything that you find memorable, noteworthy, please don't hesitate to share it. You can find Headway on Twitter, Headway.io, Instagram, Dribble, YouTube, like all of the above. And yeah, we appreciate any connections that we can make. So don't hesitate to reach out to us. All right, let's get started. So let's talk about right tool for the job. We use that phrase quite a bit at Headway, and we do our best to not use that phrase as simply an appeal to use our favorite language. We know that we all have our favorite tools that we like to use, and we've seen them used with great success, either personally or second-handed. And we want to make sure, though, that we're doing our best to prescribe a tool that solves the problem that we're faced with. And that problem often involves finding more than just a language, right? It usually involves finding the right storage system, finding ways that you can communicate from that system either to individual users broadly throughout the system. So making an entire community announcement. There's needs that the system presents by way of communication that help inform what the right tool is for the job. There's other things too, like you've got authentication. How are you going to authenticate users, identify them in the system? How are you going to document your system? What are you going to do with version control so that the history of this application you're writing is organized and maintainable? How are you going to facilitate different environments? So are you going to release to a development environment, consider a staging, finally production? How are you going to facilitate all of those things? So when we talk about right tool for the job, we've got all of the above in mind. It's not simply what is my favorite language today and how can I get the rest of my team to buy into it. Okay, so with that understanding, with right tool for the job being comprehensive and not narrowly focused, one of the ways that we want to measure our prescription as to whether or not something is the right tool for the job, we want to consider the complexity of a project, complexity of a recipe that we would prescribe. So think about two categories of complexity. So there can be accidental or essential. If we think about accidental and we define that as I may prescribe a tool, a library, a technique to a certain problem space. Accidentally, that's going to introduce complexity if that tool, library, technique doesn't fit the problem space well. And so I'm going to have to live then with that complexity, or my product team is going to live with that complexity accidentally. I didn't fully understand the space. I didn't fully understand the problem. I didn't quite know the tool that I actually was using. Again, accidentally, I introduced complexity in the system, and that's something that we want to try to control. We want to minimize. Right now, that's different than essential. So essential complexity would come from simply this problem that I'm trying to solve. It's a complex problem. So no matter what tool I prescribe, there's an element of complexity that can't be avoided. So that essential is not something that I want to try to solve this morning, but accidental is part of what we want to talk about. How do we minimize accidental complexity, and why would Elixir be a potential solution to that goal and that problem? Okay. All right, so let's take a look at when I'm referring to an application, what do I mean by that? Here's a real rough outline of different ingredients that would go into an application, one that Headway often ends up building and designing. So there's usually this back-end node within the system that we design, and that back-end node plays a role in facilitating between a whole bunch of other nodes. In this case, there's 9 on the screen, right? So you've got authentication service, you've got a web front end, possibly have a mobile front end, you've got a mail service, push notifications, social networks you want to communicate to, metrics gathering service, database, and file storage. These may be broad brushstrokes, but these are very frequently the number of nodes that are required of a backend to facilitate between. And so there's a bunch of interaction happening within this diagram. You've got requests coming from the front end, either that be web or mobile, and you've got database requirements that are on the other side, which you need to reconcile. You need to make sure that they're consistent, that your data is not being corrupted from the indirection. How do you facilitate the communication that happens in such a diagram? Let's keep moving here a bit as we look at some of the techniques that we use and that we've been successful with. So, all right, so how do you facilitate that interaction, that concurrent action that happens? Well, we're familiar with background workers, familiar with webhook notifications. We might incorporate polling at one point. We may have a retry mechanism when something fails. You would just retry it. You may cache information. You may employ pub sub so that you're trying to push and pull information at as near real time as maybe you could, at least sufficient for the needs of the system and your users. So those, if we consider those as techniques, those techniques then introduce dependencies. If I have a background worker that I want to use in order to facilitate the sending of email to a user. So if I went back to my diagram, mail was one of my nodes, right? So if that backend needs to communicate to my mail server, I may use a background worker to do that. So the main backend can continue to do work. Well, if I introduce the mail server and a background worker, I'm bringing additional dependencies. I'm having now that worker is going to likely be an operating system level process. That process needs to be monitored. It needs to be brought back up. And so now I've got another process I need to check on, plus an application to monitor that process to make sure it stays running and recovers if it fails. There's state within those workers, which I need to coordinate between other nodes. The techniques bring about more dependencies. And when you have more dependencies, inevitably you start to introduce more complexity and more maintenance, and your product team's knowledge has to grow in order to support this ever-growing system. All right, so let's start to dig then into why Elixir can be advantageous. All right, we'll start with a brief history. So there's roots of Elixir in the 80s. You will see Elixir having started as having been started by by Ericsson when they wrote Erlang. And part of the problem they were solving in the 80s with Erlang was to build concurrent systems that were fault tolerant, that ran on low power devices. So telecommunications, you can imagine, has lots of concurrent requests coming in and out, and those requests just can't fall apart. What happens when when one of those messages is dropped or a node in the system falls apart, it has ripple effects. So how does Ericsson needed to solve that problem by building a system that could recover, that could be fault tolerant, so that again, when a node went down, there'd be some assurance that it would come back up on its own. It would recover. It would be fault tolerant. Well, when they invented Erlang, I believe it started in '86, and it wasn't until '98 that it was open sourced. So Erlang has been around now for, well, since the '90s, right? It's been actually since the '80s, but available to the public since the late '90s, and we've seen adoption of it. Now, Erlang itself is maybe a difficult language to write, but notice we're not talking the Erlang advantage, we're talking Elixir. So Elixir gives us the conveniences of modern development. Something's a friendly way to write language that leverages that power and that foundation that Ericsson started back in the '80s. All right, so again, there's problems that they solved in the '80s, but there's nothing new under the sun. We are trying to solve very similar problems today. It's often, though, easy to overlook how those problems map to the same telecommunication problems and challenges that they faced in the '80s. So telecommunications it's similar. You've got messages coming and going. If you looked at our diagram, there's 9 nodes with the back end facilitating those messages between nodes, messages coming and going. When one of those nodes goes down, what do you do? How do you recover? Well, nothing new under the sun. Erlang has solved this for now a couple decades, and we get to leverage that with Elixir in a way that makes application development quite a bit cleaner, predictable, more performant, and just generally it's a good fit for the problem space. Okay, so let's dig in a little bit into how Elixir and Erlang are helpful with the tools that it provides. What specifically does it offer us? So OTP, Open Telecom Platform. When we refer to OTP, we're referring to as a collection of libraries and tools. So there's test framework that we get with OTP. There's debugging tools. There's Erlang compiler. I got debugging tools in there twice. Databases that we get with Erlang. Now those OTP, again, it gives you a solution which is different than if I went back to my application map. Those are all separate nodes. They're all distinct. They stand alone. And so you have to build the glue in between. You have to assemble those nodes in a way that they will work together, whereas OTP is giving us, it's been designed to work in concert with one another. So, all right, so OTP has been designed using the actor model. And when we talk about the actor model, you can think about it as a mathematical model of concurrent computation. Okay, that's by definition what the actor model is. Actors within the actor model, they can make local decisions. They can maintain their own state. They can create more actors, right? So one actor can say, I want to do more work, and they would create additional actors in the system. If actors want to talk to one another, they can through message passing, but one actor cannot affect the state of another directly. They have to send a message and ask that actor to make a change. So it's a mail system, right? It's again similar to telecommunications. Messages are being passed back and forth, and you can ask one node in your system to do a thing. You can't force it to do a thing. All right, so that actor model is what has been used to build Erlang and consequently Elixir. All right, so let's keep rolling here. Here's an example of what a process would be in Erlang. So The actor model, if you think about your system, you've got a number of actors within that system. And if we move away from that terminology actor and think of them as processes, we can start to see what a process does then within your application. So a process stands alone within your application. Process can receive, just like your mailbox, can receive a message within that mailbox. It can do a number of different things, like I've already mentioned. It can spawn a different process. It can send a message from itself to a different process. Or it can process the request that it's received and change the state within itself. Let's see here. I'll show you an example of some code here in a minute. Processes, though, you can distinguish them from operating system level processes in that they're very lightweight, like very lightweight. You can spin up many thousands of processes on a single machine. And each second will take a microseconds to start. They're very quick. They're basically free. And so it's different than, again, if you looked at the application diagram where you've got 9 nodes, if you're having to facilitate all that, those processes come with expense. They take time to spin up. There's work to monitor them. These processes within Erlang, they're almost free. You can spin them up, you can stop them, you can restart them with almost no cost. Okay, so here's an example, like the hello world of processes. If I wanted to spawn a new process, I could use the spawn function of the kernel module. I can put a specific message, print it back out to the screen, make waves, and then that process is going to end. It's just going to do one bit of work, and then it's going to end. And we can confirm that it ended by asking the process module if the process ID, in this case 0.104.0, if that process ID is alive or dead, and in this case it is dead, as we can see by the output of false. So that's the most basic example of what a process would do. I want to ask it to print a message and then exit. Now, obviously that is a foundational example. There's common needs that you will have in designing a system where you're going to have to leverage processes in a similar way. You're going to have processes that need to be long living, that need to restart under certain circumstances, that may need to do work at a specific scheduled time in the future, that need to track state. Processes are going to be asked to do a whole variety of things. And thankfully, we get a collection of behaviors that Elixir gives us so that we don't have to constantly redefine what those processes should do. There's a behavior which you can think of behaviors as an implementation, as an interface that you might be familiar with from object-oriented languages. So the behavior gives us definition, gives us a framework that we can use. And this would be an example, a couple examples of implementing the parser behavior if you were looking to parse JSON, YAML, or other lightweight portable formats of data. Now, there's this example using parser. There's a couple of the more common examples or common behaviors that we get from Elixir: gen server, supervisor, application. There's others too, but these 3 are commonly used, and you can get a lot of work done by using these 3 modules. So let's just dive into each one of these briefly, individually. Gen server. So gen server stands for generic server. That's useful if you are looking for a process to keep state, if you want code to execute asynchronously, if you want to put that process within a supervision tree. Let's talk about supervision tree for a minute. Supervisor is another behavior, and as you might imagine, as the name implies, supervisor is responsible for managing the processes within it. What happens if a process fails for some reason? Well, the supervisor would be responsible for restarting that process. What happens if you want a process that only lives for a specific amount of time, then you want it to end? The supervisor could be responsible for ending that process. And then finally, application would be a module, or a behavior rather, and a module that allows you to define at the highest level what your application should do, so that the application could stand alone, or you could use it as part of a bigger application. It could just be one element within a broader system. So common behaviors, you get a lot of information, a lot of definition from Elixir. You can write your own behaviors. You can extend these. There's a lot of power available to you just out of the box. Okay, so let's keep going here. Let's take a look at just distributed Elixir and scheduling just briefly. So if you've got thousands, as I mentioned, you've got thousands of nodes within an Elixir system. You've got to be able to keep track of that work somehow. There has to be some ability for that work to happen in an orderly way, in a way that you can inspect, in a way that you can prioritize. But that's within one box. What if I've got a system that needs to scale to the point where one physical machine, right? One machine is not sufficient. I need to extend horizontally out with my application in order to serve at scale. Extending out comes at very little expense. There's very little involved in that using Elixir, because message passing supports distribution of that work in a way that's very similar to whether I'm confined to a single box. So, excuse me, if I'm passing messages within a single box back and forth, I can also pass them from box to box and have a predictable result. So distributed Elixir, I can get scale by simply adding nodes within my system, and those nodes will talk to one another. The scheduler is responsible for making sure that work gets accomplished. So the scheduler is going to say to whatever process, do the work. Different process, okay, do the work. It's happening orderly and on time, and across distributed nodes horizontally. So besides just being able to add nodes, there's one of the hallmarks of Elixir you'll hear often is that it's performant, it's fast, and it is. And not only is it fast today, but as hardware continues to evolve, as your machines add more and more cores, you're going to get an increase in performance simply because those cores are going to be utilized by the Beam, by the Erlang virtual machine, without you having to do any work. You're going to get additional workers in your system essentially without you having to even write an ounce of code. So it's quick today, and it's only going to continue to grow as hardware evolves in the future. All right, so let's take a look at some success stories here. How is this actually playing out in the marketplace? There's a few quotes that I've picked up on Twitter here and there that I've found pretty eye-opening. Heroku, you can see they have been using Phoenix, which is the web framework of Elixir. They've been using that to power their dashboard. Heroku is it's big, it's huge. It's facilitating a lot of the web. We use it often for applications at Headway. So they're using five dynos, 5 processes. Their biggest dyno is using 256 megs of memory. to empower their entire dashboard. And it's just a lot of traffic given how big Heroku is. For only 5 dynos, that's impressive. Font awesome. They're using Elixir Lang and Phoenix. They're seeing 100 to 250 microseconds. Prior to Elixir, I'd only really seen milliseconds as the measurement for request time. Microseconds wasn't really even a thing, and they're seeing that with Elixir, which is really impressive. This one from one of the bigger contributors within the Elixir community. He said, kind of tongue in cheek, but he said there's I replaced 50 Ruby servers with 2 Elixir servers, which is impressive, right? There's more context there, I'm sure, but that is a remarkable exchange of work and overhead for simply two Elixir servers. Taxjar has an interesting blog post, which is linked at the bottom there, and they point out that they're performing hundreds of millions of sales tax calculations a month for entire platforms for Fortune 500 companies, and they brought down their server costs substantially. So you can read that post. I'd encourage you to check it out. The gains that they've seen are not just in cost savings, but in capability, product team, production, happiness. There's really all of the above they've seen in their move into Elixir as the engine that they use. It's their best tool for the job. Okay, in addition, so those are some secondhand examples. Headway, we've seen Elixir now for a couple of years solving some pretty difficult problems. We saw one very challenging project in the transportation industry that we leveraged Elixir to great success. Internally, we've been using it to build an application named Birdseye. Just a quick story about Birdseye. So this past summer, we had the application in a state where there was an Elixir backend and there was a single page application front end, and we were wrestling with performance issues on the front end. We're wrestling with some UX challenges that we simply were struggling to solve. And we had made the decision that we should explore a newer library that the Elixir community has come out with that pairs with the Phoenix framework named LiveView. We should explore that to see if LiveView could possibly solve some of these problems that we were dealing with in the front end. We spent a few days exploring that, just trying to get a sense of whether we could actually solve these problems. Confirmed along each step of the way that, yeah, I think this could actually solve our problems. Decided we were going to make the switch. And so we rewrote our front end in LiveView in approximately 2 months. It solved our performance issues, it solved our UX problems. And since the beginning of October, we've been able to onboard some alpha users. We've been able to use it internally in a way that's been productive individually, but also as a product team. The Birdseye team has been able to turn their focus from performance and bug fixes in the UI to feature development toward improving the experience instead of dealing with regressions. And so the LiveView library is it's very interesting. It's distinct because of the concurrent, fault tolerant, because of the nature of its core, again, which started back with Ericsson in the 80s. It would be difficult to replicate that without the hallmark features of Erlang. So, all right, so we want to give some time for some questions, kind of breeze through that. See, Jacob, are there questions that anybody has posed?
Yeah, we have a couple questions here in the Q&A panel, Tim. If you can either read them or I can read them off to you.
Okay, yeah, I just opened it. So, all right, Gunnar, yeah, thanks for checking in. What is the most common approach to managing downstream WebSocket connections and storing data received in Elixir apps? Well, managing WebSocket connections, at least using Phoenix, is something that we have a solution for when we adopt that framework. So those sockets, channels as they're called in Phoenix, are great. You can quickly adopt them. You can use them. You don't need to introduce any additional nodes. You don't need to introduce Redis, like I've talked about a little bit. You don't need to introduce extensions to Postgres. You have everything you need in order to manage WebSockets using Phoenix. And then storing data received in Elixir apps. So you've got additional options there too. So you can store data using traditional database, Postgres, MySQL, MS SQL, document storage database like MongoDB. You can use those options. You also have, if you need more short-term memory storage, there's Amnesia or ETS, which is part of Erlang. So you have additional options without having to introduce another node into the system, whether that data is coming over a WebSocket or traditional HTTP. There's some helpful tools for you that come with OTP. So hopefully that helps, Gunnar. I'm happy to clarify if I didn't fully answer your question, so let me know. And then let's see, another question. Many examples I see of successful Elixir seem to be moving from something else once a level of scale is hit. What's the perceived tipping point where it makes sense to build an Elixir right away? Yeah, so that's a good question. And we've had these conversations internal at Headway. What we're seeing more and more is that the speed of developing an Elixir is not different than other languages. And so it becomes not a question of when should I adopt it? Do I need to have 1 million users, 10 million users? When? It's more a question of why not now? Like, is it going to slow me down in developing this product in a way that is detrimental to the goal? Is there a better tool? Again, that's the main question, right? Is there a better tool for this problem? Better might be speed to market. Better might be interaction with complex UI. Better might be compliance with privacy. There may be reasons that a different option could be better, but if we're simply talking about the speed to develop an application, it's generally, Elixir is not really going to slow you down. If you're experienced with it enough, you will be just as productive. And so I would say it's not so much when, it's more of a, does this fit what we're trying to do? Hopefully that helps. Feel free to, again, follow up if I can clarify any of that. All right, so let's see, Ronald, yeah, thanks for checking in. Can you describe your environment? Programmer's local environment, development, staging, production. Yeah, so that's, that is exactly it. That's often what we end up finding with client work is local development. We've got a development server, a staging server, and a production server. And one of the benefits to Elixir, an additional benefit, is my local environment doesn't require me to install and mimic a bunch of additional nodes that the servers may have, right? So I don't need to spin up Redis, for example, or a PubSub node, whatever might be responsible for facilitating PubSub. If I, as a developer, bring Elixir onto my system, the application written in Elixir onto my system, I have what I need. I can spin up that Elixir application and boom, I'm off and running. I don't have to make sure I've got additional nodes up and running in order to leverage this application and contribute to it. Okay, let's see, Gunnar, Yeah, this is probably more of a Postgres question, but related to the first one. Does Ecto Postgres have any constraints on read and write speed when processing stream data coming in by the second? I don't think that's a constraint. Ecto and well, not that I'm aware of. I guess, Gunnar, I don't know that Ecto has a constraint on that. You may introduce a constraint based on how many connections you allow your application to have to Postgres. So you may say, I'm going to allow 100 connections. There's a pool of 100 connections. There's a constraint there that may limit read and write between Ecto and Postgres. But as fast as Postgres can consume or present information, Ecto should be there to push and pull that very information. So let me know, Gunnar, if that helps. But I can't think of anything beyond traditional database constraints and then simple connection pooling. Okay, another question, comparing with Erlang, what is the Elixir advantage apart from syntax? Yeah, I mean, syntax is a big one. Erlang, I think, you're gonna have a hard time finding people that want to write Erlang every day. And that's a significant, maybe impossible hurdle to overcome if you're trying to build a development team and build a product that's maintainable. Elixir makes programming, quite frankly, makes it pleasurable. It's like if you've written Ruby is probably the king of that discussion in terms of readability and delight when writing. Elixir's not that far behind. It's quite great to write. It's easy to read, and there's certain hallmarks of the language which aren't distinct to Elixir. They're part of Erlang, but being able to pattern match is great. I mean, it's kind of a revelation once you start writing it. So I guess the other thing maybe that the Elixir gives an advantage to is, over just writing raw Erlang, is you've got libraries now that the community have contribute to as Elixir libraries and not as Erlang libraries. And so you would be, you'd be hunting for some solutions that Elixir gives.
All right, Tim, we got a question actually over on YouTube. He says, morning guys, Josh here. Tim, thanks for doing the talk. My question is, do you find yourself reaching for Elixir over and over for a specific portion of those 9 nodes of an application? For example, if you decided to build an app in, say, Python or Ruby, is there a portion of the application that you tend to reach for Elixir because it solves that piece in a more desirable way?
Yeah, that's a good question. So to clarify, if I look at those 9 nodes don't necessarily go away, right? So those 9 nodes will still likely exist in an Elixir designed application, an Elixir written application. The difference though is how those nodes are maintained and who communicates with them. Elixir gives me ability to communicate with them in a way that other languages just don't. Or at least if they do, I have to add yet additional nodes. So 9 becomes 10 or 11 or 12, or there's interconnected dependencies between those nodes, which just increases the complexity of that overall system exponentially. So yeah, it's a good question and a point of clarification that I should have made, that didn't mean to imply that those nodes necessarily go away. It's that Elixir gives me the ability to facilitate between them in a way that's really, really unique and really helpful. So hopefully that helps. Now with that said, there are a couple examples that I could get into. Like if I had short-term storage, I could use Amnesia or Ets that maybe would replace what I would be using Postgres for, or Redis. There are some storage mechanisms within the Beam, within Erlang, that I can leverage that could actually eliminate 1 or 2 of those nodes, but that wasn't necessarily the intent of that diagram. Let's see. So yeah, Gunnar asking about downsides to Phoenix Live View. Yeah, I mean, it's new, right? So downsides are that it's new, and we don't see it all over the web yet. It's not perfect for everything. Like it's a stateful connection, so you need to have a connection to the web if you're trying to develop a single page application or single page like application for a mobile device, but that device might be offline at times. Then you're kind of stuck. You're not going to have a good experience with a live view app. Now, maybe that will change. Live view is going to continue to evolve, and there may be a solution for that scenario, but you have to know the domain that you're solving the problem in. You have to know that well enough to say, yeah, live view gives me the level of interaction I need. I have a stateful connection. I know the user is going to be online, or at least would be required to be anyways, regardless of technology. And yeah, live view is, at this point in our experience, it's plenty stable. There's no need to wait to adopt it if it again fits the criteria that your problem calls for.
Awesome. I think that's all the questions today, unless anyone else. Oh, looks like there's one more actually in the chat here from Benjamin here. What's the learning curve of Ecto versus Active Record? Do you find either one easier to use, and what's more difficult to do in one versus the other?
Good question. Yeah, Ben, that's a good question. So the learning curve for Active Record is quite a bit lower than Ecto, at least in my experience, and I think most people would say the same. Active Record gives you so much convenience that it's hard to fault Active Record, really. It's a beautifully written library. With that said, there are limitations, and there are certain versions of Active Record that have led to pitfalls, thinking like N+1 issues, that there weren't guards put in place within the library that that now they're starting to adopt. And I think some of that adoption has been inspired by the Ecto library itself. So thinking of associations, if you don't explicitly load association, in the past, Active Record would do that for you. Magically, it would just load the association, but that could be a performance problem. That's not something that you necessarily want or need. Ecto would prevent you from doing that by saying, this association isn't loaded. You have to explicitly ask me to do that. So there's a little bit more friction in a good way, in a productive way, but with that comes, increased learning that's needed to be a user of Ecto. Something simple, like what's easier, a specific example, what's easier in Active Record than an Ecto, and maybe vice versa. If I just want to grab the count of a collection of objects in a table using Active Record, there's a method on my model for me to do that. I can call .count and get a count back. If I want to do that in Ecto, I need to actually write the SQL, what at least what appears to be SQL. I need to use the query language within Ecto in order to get a count of a table. So that sounds really simple, but if you're new to Ecto and you go to look at it, having maybe come from Active Record, you would feel a little bit of friction there, saying, well, that feels verbose. I should be able to just get the count of a table like I'm used to in Active Record. However, once you learn it, you find that knowing Ecto, then the ceiling goes way up. Like I don't hit limitations that I may feel with Active Record once I know Ecto. It gets me closer to the language that I'm trying to write, which is SQL, in a good way. There's reasons why we have wrappers, why we have relational mappers. We don't always want to write SQL. This strikes a balance between writing raw SQL and the convenience of the language in a way that is really great. I mean, it's impressive. So what Ecto does essentially is you're really just dealing with data structure. It looks as though you're writing SQL, but all you're doing is changing the structure of data until you have that structure shaped the way you need it. Then you pass it to your repository object that will communicate with your database. So being able to change and evolve that data structure over a series of function calls is a really powerful thing. You can start to compose queries in a way that Active Record is maybe a little more challenging to do. So hopefully that helps, Ben. If not, please mention it.
Awesome, thank you, Tim. We have one more question from Gunnar, and I think we'll be wrapping it up just to be mindful of our time today. Thanks everyone for all the questions. But Gunnar asked, does Phoenix have anything like Rails plugins?
So Rails plugins have kind of been replaced by engines, I suppose. I'm not sure, Gunnar, if you're referring to gems or if you're thinking of Rails engines. I may just be going back too far, so my apologies if this isn't quite what you're asking, but if you want to bring a pre-made feature, let me think of one here. Let's say I want to have an administrative dashboard. One thing that we've used at Headway quite a bit is the Rails administrate. There's administrate gem, which allows us to empower administrators within an application to manage data at a higher level than individual users could. They just have greater permission. And so that gem has really been really helpful to us. We've used it a lot. There's an equivalent of that in the Elixir community. I wouldn't call it a plugin. You'd refer to it just as a mixed library. And so that application is run within your umbrella. So you can think of it as one process which is run as a child of your application, your parent process. So to answer your question in short, yes, it just doesn't take the form of a plugin. It's seen a little bit differently. And also the Rails community has got a few more years behind it. And so you may find certain plugins, quote unquote plugins, that the Rails community has that haven't yet found their way to Elixir. We're seeing those fewer and far between, and honestly, I don't really have an example of one that an issue that we've seen to date yet where we wanted a library, but there was not an equivalent in the Elixir community.
Awesome. Yeah, I think answered. He said it was a friend's question, but I think you answered it well. So
okay.
Awesome. Well, we'll wrap it up now. Thanks, Tim, for sharing all this awesome knowledge and experience today. It's super helpful for everyone. As a reminder, this event was recorded. It'll be available on our YouTube channel, and it'll also be available in your email soon. Later this week, we'll have all the links that he may have mentioned in the presentation on the landing page where the video will be too as well, for you to click on, and you don't have to hunt for them on your own. So thanks again, everybody. Be sure to stay updated on future events. We actually have another event later today on building landing pages for products. We have one tomorrow with Andrew on building no code. Building an app with no code, and is it a good option for you? What are the benefits? What are some of the restrictions of it? So I'll share that link in the chat there. So if you're interested in learning about any of our events, you can head to our website at headway.io, and hopefully we'll see you soon. So everybody take care.
Thanks, everybody. Take care.